Okay. So Spearman rank order correlation. So the when we are going to use the Spearman rank order correlation. So Spearman's correlation coefficient. This symbol is actually a Greek letter for R. That's rho. That's why in some reference that is Spearman rho correlation. This is the letter R for the Greek alphabet. So signified by R sub S. Okay. Okay. So the Spearman's rank order correlation is the non-parametric version of the person's product moment correlation coefficient. So the person product moment correlation coefficient is very applicable only to the continuous data and normal distribution. Otherwise, we can use the Spearman's rank order correlation. Okay, so as what I have said kanina, that this letter, I hope you can see my cursor, this letter is a Greek letter R or Rho, okay, in the Greek alphabet. Okay, that's why some of the references, the Spearman's rank order correlation is also known for Spearman's Rho correlation, RHO. Okay. Okay. So what are the assumptions of the test? So we need two variables that are either ordinal, interval, or ratio. Although we would normally hope to use the person product moment correlation coefficient or correlation rather on the interval or ratio data, the Spearman correlation can be used when the assumptions of the person correlation are marked violated. However, Spearman's correlation, okay, determines the strength and the direction of the monotonic relationship between your two variables rather than the strength and the direction of the linear relationship between the two variables, which is what person's correlation determine. So in other words, the Spearman-Rho correlation determines only the strength and the direction of the monotonic relationship. So what is monotonic relationship? So this is the two. These are the illustration of monotonic and non-monotonic relationship. A monotonic relationship is a relationship that does the value of one variable increases, so does the value of the other variable. Or as the value of one variable increases, the other variable value decreases. So the first, these two graphs or these two scatter plots are examples of monotonic. Here, okay, it's linear. Okay, the first one is linear. The other one is not linear. Okay, relationship because it's a curve relationship. However, it does also as x increases, y also increases. Okay, so the other one is a non-monotonic relationship because it does not follow that as the one variable increases, the other increases or decreases. So it's not monotonic because there is a peak, okay, within the curve. So why is a monotonic relationship important to Spearman's correlation? Um, the Spearman's correlation measures the strength and the direction of the monotonic association between two variables. Monotonicity is less restrictive than that of linear relationship in the person product moment correlation coefficient. For example, okay, as we can see here in the middle scatter plot, okay, the relationship is still monotonic but it is not linear. Okay. The monotonic relationship is not strictly an assumption of Spearman's correlation. Um, that is, you can still run Spearman's correlation on the non-monotonic relationship to determine if there is a monotonic component in the association. However, uh, you should normally pick up a measure of association, such as Spearman's correlation, that fits the pattern of the observed data. That is, if the scatter plot shows that the relationship between two variables looks monotonic, you would run Spearman's correlation because this will then be the measure of the strength and direction of this monotonic relationship. On the other hand, if the relationship appears linear, which we can see here in the scatter plot, okay, you would run the person's correlation because this will measure the strength and direction of any linear relationship. So the uh, the differences between the uh, person product and the Spearmans is the Spearmans only measures the strength and the direction of the monotonic. In the person product, it is very strict because relationship, degrees, and the strength, okay, in the linear relationship. So that's the difference between the Spearman and the person product. Okay, so this would be the uh, formula for the person, not person product, the Spearman rho. Okay, there are two methods to calculate the Spearman's correlation, depending on whether the data does have tied ranks or the data has no tied rank. Okay, the formula. Okay, this is the formula if there are no tied rank. So kung walang nag-tie, so this would be the formula. Okay, the D here stands for the difference in pairs rank. The N here implies number of cases. Okay. Now, if there are tie, okay, if there are tie, then this would be our formula. Okay. So we have still the differences, okay, of the ranks of the first column or the first group, and then we have here the differences of the mean of the ranks, okay, and then I for the paired score. Okay, so let's have this example. Consider the data gathering the marks achieved in a math and English. What is the association of the two subjects? So in this case, the general form of hypothesis or null hypothesis of a Spearman's correlation is there is no monotonic or association between two variables. In other words, the alternative hypothesis would be there is association between the two variables. So remember, we are making inferences here. Okay, so we are making an inference from our sample to the population that the sample is supposed to represent. So, however, as a general understanding of an inferential statistics test, it is not often included. The null hypothesis statement, for example, used in this kind of this example, our null hypothesis would be there is no monotonic relationship between math and English marks. Okay, so that would be our null. Okay. So for our null, there is no association between math and English mark. Okay. Now in this case, as we can see here, okay, we can actually before we can move to the computation, we are going to rank, okay, rank the the English and the math. Okay, let's move to Excel. Rank. Okay, here we have two examples. We have two formula for the rank. Okay, if this rank formula we are going to use, we can have, if there are tie, okay, or if there are tie elements, uh, the Excel will get the average of those ranks. Okay, this one, okay, they are not going to get the average of the ranks, of the tied ranks. So we're going to use this one. Okay, then the number that we are going to rank, then comma, the references. Okay, what table or what data are we going to rank? So this one. Now take note that we have this range of the reference. Okay, we are going to place dollar sign here so that the as we move our uh, formula, okay, these references will not move. Okay, comma, order, it could be ascending or descending. Either of the two will do. Okay, close. And then we have this one. So here, 56 is rank 9. Okay, then, okay, so here we have I rank 61, 61, that is 6.5. So 1, 2, 3, 4, 5, 6, no 7, no 6, that's 6.5, 8, 9, 10. Okay, same what we're going to do in the uh, math. We have the rank. Okay, let's have this one, the reference. Oops. Okay, but for the reference, we're going to place dollar sign here. So it will stay permanent whether we drag the table. Okay. Ah, it should be 0. Okay. Close. Okay, so in other words, 9 is fourth, not 9, 66 rather. 66 is 4, 70 is second, 40 is 10. In this case, we can see here, okay, we have tied. Okay, we have tie example, not example, we have a rank that is tied. Now, if we go back to the presentation, okay, we are going to use, okay, the second, okay, the second formula, okay, because there is a tie. Okay, so let's try to continue. Okay, in the formula, summation of the difference of x minus difference of x in its mean. So in other words, we're going to get the mean of these ranks. Okay, so average, okay, of the ranks, that's 5.5, and then the average, okay, is still 5.5. Let's put some colors para hindi malito. Okay, next is we are going to subtract the rank by the mean. So here we have 9 minus 5.5. Okay. Okay, and then here again, the rank minus 5.5. Okay, and then we are going to get the sum. Hindi pa pala. Okay, 0 yan because the rank is the variant, not the variance, the deviation is equal, the total deviation is equal to 0 if we are not going to squared. So, let's square muna this one. Okay, and then this one squared. Okay, enter. Then add those squared. Okay, now in the formula, the summation of the product. Okay, so this is, let's add some summation pa pala, the product pa pala. So here we have this one times this one. Okay, and then sum. F1, F2, not average. This must be sum. Kaya pala. Ito, sum din ito. Kaya pala ang likit. Okay. Sum. And then sum of these. Okay, so we have 50. The sum of the product is 55. The sum of the squared in the English is 52. The sum of the difference of the squared of the difference rather, is equal to 82.5 in mathematics. So now we can have the formula. Okay, so you have for the row, that's equal to the sum of the product. So this is 55 divided by the square root of the product of the the sum of the product of the different square differences times this one. Okay, so that's equal to 0.668. Okay, so that's uh, the raw coefficient. Okay, let's try to migrate to wala na po nakashare. So, okay, since may nagtay, so our formula, okay, that's equal to the summation of, okay, of the x I, the mean times the y sub I minus the mean of the y. So you have, okay, uh, here. Ah, 6.7 pala. Round off. So in this case, this indicates that we can actually we can still use the interpretation of the coefficient of the Spearman rho. Okay, the person product. Okay, so if you can still remember with the interpretation of the coefficient uh, in the person product, okay, 0.67 indicates that there is a moderate positive relationship between the ranks, okay, of the individuals in the math and English examination. So that is, the higher the rank in the math, the higher the student has the higher the student, okay, would be in English in terms of its rank, and vice versa. So it means that if the rank in English is higher, the rank in mathematics is also higher. Okay. Conversely, if the rank in English is low, the rank also in mathematics will also low. Okay. So how it is important, how do we interpret the statistical significance in Spearman correlation? Um, it is important to realize that the statistical significance does not indicate the strength of Spearman's correlation. In fact, the statistical significant testing of the Spearman correlation does not provide any information about the strength of the relationship. Thus, achieving the significance in determining its value. Okay, for example, if the p-value is 0.001, okay, it does not mean that the relationship is stronger than if you achieve a value of p which is 0.04. This is because the significant test is investigating whether we can reject or fail to reject the null hypothesis. So if we set 0.05 level of significance, achieving the statistical significance in the Spearman rank order correlation means that we can be sure that there is less than 5% chance that the strength of the relationship we found, okay, in our rho coefficient happens by chance if the null hypothesis were true. So that's how we are going to bear in mind if we are going to report the Spearman rho correlation. Okay. So this would be the way of having the statistical the computation, the manual computation in the Spearman rho coefficient if it happens na may nag-tie. Okay. Now let's try to use the megastat. Nag-highlight ang cell, it means we are going to reject the null hypothesis. So in other words, remember that the null hypothesis in our what to call this one example is that there is no association. So since yung p-value natin is Okay, in this case, the cell here is highlighted with yellow. It means that we are going to reject the null. Okay, it means that there is association between the ranks of the English and mathematics mark. Okay, so yun. So to review, we go to megastat, we go to non-parametric test, and then we go for Spearman coefficient, and then highlight only those numbers. And then click, and then we click correct for ties. Then click OK. Now what will happen if there is no tie at all? Okay, so what will happen pag walang nag-tie? Okay, okay. So in this case, as you can see here, okay, we can say na wala nang nag-tie dito. So same pa rin, the null hypothesis, there is no association between math and English. But in this case, we can have, in this case, we can use the first formula because walang nag-tie sa kanila. Okay, so let's go to Excel para makita natin, para mas madali rin mag-compute. And 0, and okay. As we can see, okay, walang nag-tie. Okay, now we can get the difference of these ranks. The difference, after we get the difference, we squared it. Square the difference. After squaring the difference, let's get the sum. Okay, so the sum is 93. And then we go to Spearman. Okay, here. And then we are going to highlight these, okay, numbers. No, let's clear. Let's go back. Megastat. Then we go to Spearman. And then highlight. In this case, we are not going to check the correct for ties because as we can see, walang nag-tie sa mga ranks. Okay, click OK. Okay, so here we have 0.67, 0.673 or 0.67 yung nilagay natin. And then naka-highlight si cell, it means that the p-value is less than 0.05. So in other words, we're going to reject the null hypothesis. Okay, if you can still remember with our null hypothesis, we state that there is no association between the math and English marks. In other words, since we reject the null, okay, there is association between the English and the mathematics mark or mathematics exam. Okay, so that's how we are going to have the Spearman-Rowe correlation. Okay,